Wasabi, you guys. I am going to do problems that I hate the most. That is physics. Now, I have the G main physics here. Uh, but you might already know I hate physics. But before we get into this monstrosity though, let's see how much physics I can remember. So I'm just gonna start with this course challenge. Oh God, we're on a bad start. Timothy kicked the ball on a level surface of 45 degrees and 30 degrees with the same total speed shown below. With launch angle results in the greater maximum height. Wait. Oh, which launch angle results in the greater maximum height for the ball? Same speed. Well, obviously 45, right? Okay. I'm literally just imagining things that's there. I'm not really calculating anything. A standing sound wave is created holding by a vibrating tuning fork with frequency 1000 Hz near the end of an open tube. Which of the following frequencies can also exist for standing waves in this tube? I don't know. 500? Because it cancels out? Okay, that works, I guess. Oh boy. A box moves 20 meters horizontally as a force. Wait, and what is the work done? Shit, wait. Uh, how does it go? Wait. A box moves 20 meters horizontally as a force. A box moves. What is the work done? Shit, what was the formula? Work, work, uh, work. What was the formula for work? It was FD. Okay, force times distance. So it's like 800. Force as a force is applied downward. Wait, a box moves as force is applied downward? Why would you need to apply force downward? So I guess 40? Because that does not the applying force downward does nothing. Okay, so I guess it is 800. Okay, well, I guess negative 800 then. What is it? What? Oh my God. Okay, why? Can you explain why? Actually, use a hint. Only force parallel with the displacement does work. Oh, wait, what? Only force parallel with the displacement does work? A force F is perpendicular with the displacement? So does zero work on the box? I don't remember that fact, but okay, I believe you. Okay. Drops a basketball from a height of 10 meters on Mars, where the acceleration due to wait, hold on. God damn, I hate reading. So, Onur drops a basketball from a height of 10 meters on Mars. Acceleration due to gravity is that. You want to know how many seconds the basketball is in the air before it hits the ground. Well, We have height, we have acceleration. We have initial velocity. Wait. There's no distance here. We need distance. I'm assuming delta y is distance. And we want to know how many t seconds. The distance. We don't know velocity. Oh wait. How many seconds the basketball is in the air? Wait. We want to know how many seconds. Oh yeah. Okay. So we need time, and we have time, distance. That's also velocity. So I guess we're using B. Yeah. I'm at this point I'm really just going by guess with math. A string of length L vibrates to form a standing wave with 5 antinodes. I completely forgot what that is, but I'm assuming it's like this, 5 antinodes. What is the length of the standing wave? I don't know. L over 5? Okay. Is it just L? I swear, is it just L? Okay. Well, then I don't know. Well, because this seems to be destructive. Okay, that actually makes sense. A disk with rotational inertia. I I hate reading. A disk. Okay, so I'm imagining a disk with rotational inertia of that rotates clockwise with an angular speed. Fuck. I don't know. Don't. Why? I don't know. What is the angular momentum? I don't know the formula. It's like they use like omega variables, I think. Uh, sheesh, I don't know. Let's go by units. So we see that this is 15 radians. So I guess we multiply. How do we get rid of radians? Do we just convert it to degrees? So I guess, all right, show calculator. So looking at the units, I see we just need to do 0.75 times 15, right? Okay, but what does it equal? Come on. What does it equal? Oh my god. It's this. Who made this calculator? Oh my god. It's like it's as bad as GRE's calculator. Come on. Are you serious? I can't even go back? What the hell? Oh my god. Oh, there you go. Okay, what does it equal? Well, that's ass. Okay, well, let's do, okay, well, 3/4 times 15, that's like 45 over 4. Well, actually, no. I need this to be in degrees. 15, uh, times 180 divided by pi? The fuck? I don't want to do that. Well, if I 180 divided by 15, so we need 180 divided by 15 pi, pretty much. and then 3/4. What does it equal? You cannot understand your answer. Well, I can't understand your calculator because it can't equal. Oh my god. Who made this? I don't get it. Really? Who the Oh my god. Okay. Now you work. So then so I got 3/4. And then I don't know. Okay, let's do this first. 180 divided by pi divided by, wait. Oh wait, what am I doing? No. I completely wrote this wrong. I just realized that. So it's 15 times 180 divided by pi, and then times 0.75. What do you mean you can't answer it? Oh my god. Alright, fine. Let's do this. Let's do this. Let's do this. Times 3 divided by 4. Asshole. Alright, so 2 significant digits. Ah, shit. I'm a chem person. How do I not know this? I'll just do. Oh, but I can't write it like this either. Well, I mean, to Khan Academy, this is technically 2 sig figs, but in real life, this is ambiguous. But you know what? I'm just gonna. No? Okay. Well, should be an exact decimal, like. Okay, well, I don't know. Do you want like two? What do you want? Uh, you know what? I'm just gonna not follow the rules. Can you just accept my answer? Oh my god. Alright. Maybe my answer is wrong. Use a hint. That's it? I just had to. I didn't need to. Wow. I didn't. This is fucking. I can. What? This rat? Wow. Okay. That's fine. That's fine. The uniform meter. Oh god. Fulcrum at its center. Up another upward. Oh god, I don't want to comprehend this. At which position should the upward force F be applied to keep the meter stick in its equilibrium? This is going here, and I need to go here. Wait, what am I? No, I have to push down here. It's X4. No. At which position should the upward force F be applied to keep the meter? Oh, I'm so dumb. Push upwards. Well, obviously that's just gonna rotate. Okay. In that case, if this is going here, then I need to go here at 2. I'm confused. I apply force here and force here. But if I applied here, douche, douche. Wait. Oh, if I applied here, this whole meter just goes flung this way. Oh, so I apply at x1. Okay, because this thingy holds it. Okay, that makes sense. God damn, I hate physics. Okay. A toy car coasts around a vertical loop of a track as shown below. Okay. Thanks for showing me. Friction and air resistance are negligible, like always, because to make things simple. The car is touching the track. I see that. Which set of force vectors? Oh god, no! Oh god, I'm having flashbacks. Oh god. Vectors. Why? Why do I have to see you? Which set of force vectors show all the forces on the car its position? Well, vertical loop. I'm assuming here. So here. So there's. I think it's just B. Okay. Oh shit. Oh god. Oh no! Stop! Oh god! A 1 kilogram pendulum swings. From point A to B. Oh god. The heights are relative to the lowest height. What is the change in gravity? Oh no! No! Don't give me a free response! I don't know. Gravitational potential energy? 0. Because, yeah. Okay. I don't know. What is it? Oh, N-gay. Okay. So it's the N-gay formula. Yeah, I don't remember that. Okay, well I guess it's negative 0.29. Okay. Oh my god, a fan initially rotates like this. It has a counterclockwise acceleration like this, and reaches a counterclockwise angular speed like this. How much time did this change? I don't... Why? I don't know. Where are the hints? Give me the hints! God. Rotates clockwise but has a counterclockwise angular acceleration. How much time did this change in this? Oh my god! I don't know. Well, how much time did this change? Angular velocity take? If my fan were to act like this, I am imagining that it would take 5 seconds. Oh, not quite right. I don't know. Oh, there's the hint. I don't. 12 seconds? That's a long ass. Okay. And it's longer than my advertisement. Okay. A yellow disc spins with angular acceleration. Oh my god, can we not have... I'm tired of angular acceleration. Oh god. A yellow disc spins with angular acceleration at alpha. A point on the edge has tangential acceleration A. A green disc spins angular acceleration 3 alpha. A point on the tangential acceleration 2A. How does the radius... What the fuck? Compare... Well, if there's more... 3 alpha is more than alpha. So... Wait, but then acceleration... God! This is horrible! Uh... Well, if spins with angular acceleration 3A, 3 alpha. Well, if this is faster, then the yellow has to be bigger. So then the green disk is smaller. So it has to be either A or B. It has angular, so it's fast. And a point on the tangential. Wait, angular acceleration? Tangential acceleration. A. Okay, fine, it's B. What? I am so. This does not follow the rules of mathematics. Uh, I guess 6 then. Wow, so I guess green is bigger? I probably miss. Okay, I don't know. D. I I definitely misinterpreted that question then. A child rides on the edge of a circular platform at a playground which rotates clockwise about a frictionless axle through its center. The child then runs counterclockwise around the edge on the platform. How does the angle on top of the platform change as the child runs? So if this was a carousel, rides on the edge of a circular platform, which rotates clockwise, frictionless. Then the child runs counterclockwise around the edge of the platform. Hmm. Oh, fuck. I don't remember torque. Increases because the angular. I'm gonna say A. Stays the same because of it. Wow, something actually happens. Well, good for you. Becomes more negative because it. I don't know. I don't know. D? Oh my god. I always get I always choose. Oh my goodness. Alright, thank you. What's the next question? What is a wave? Hmm. Crap. I should know this. Uh, 3. Yeah! Fucking hell. Oh my god, I barely remember analytical chemistry. Shit. Next question. A box of mass m is pushed on a frictionless ramp. The ramp has an angle theta. What is the magnitude of the acceleration? Oh no. Oh wait. A box of mass. Wait, okay, force. Force. What was the formula of force? Fuck my ass. FMA. Force mass time. Okay, yeah. Okay, so, uh, mass times acceleration. So that's how I remember it. FMA. Force is equal to mass times acceleration. Uh, we have mass. Acceleration is based on the angle. Wait. What is the magnitude of the acceleration? Okay, well, F over M. Okay, so then it's either. This looks like G sine theta. Yeah! Oh, holy hell. I never thought I would have to apply that formula again. Next question. A skateboarder rolls horizontally off the top of a staircase and lands at the bottom of the stairs. The staircase has a horizontal length of 12 meters and the jump lasts 1.10 seconds. We can ignore air resistance. Wow, like always. What is the skater's vertical velocity upon landing? I don't know. Uh, well, as you can see, we have M and we have S. And the answer says M over S. So if we just follow the units, 12 divided by 1.1, you get round to 3 6. Okay, so 10.9. Okay, so that didn't work. Damn. Okay. You got me here. Let's see. Skateboarder rolls horizontally off the top. Is there like a formula for this? There's probably some projectile thing to memorize. I don't know. Maybe there is a formula for this. Use a hint. There is a formula for this. I knew it. So it's negative 10.8. Wait! Oh! No, I put 10.9. Oh god, negative 10.8. Okay. Click each dot on the image to select all answers that apply to... Oh, what? Oh, it's not even interactive. Oh, it's one of these. I don't want to read this, to be honest. If I dropped a ball... Oh no, if I drop a block onto a spring, the block follows the pathway shown. Okay, the block is dropped. Uh-huh. Fall into the spring has been momentarily stopped by the compressed spring. The height is marked on the diagram. Okay, well, this is going to be gravitational or maybe kinetic. This might be static. This might be that. Okay, I was close enough. I was close. Oh, that's, wait, I clicked both? Oh no, I didn't mean to do that. Oh wait, is it both? Wait, I'm confused now. Oh no. Wait. Okay. So I guess this is that? It is not. Is it this? Okay, well, that... Oh, okay. A standing sound wave is created in an open tube. Pressure diagram of the air molecules of the standing wave is shown below. Which of the labeled points... Oh my god, am I not halfway? A standing sound wave is created in an open tube. The pressure diagram of the air molecules of the standing wave is shown below. Which of the labels is a displacement node? 3, because it's in the middle. That is, okay. Then 4, because that's in the middle. Okay, it's somewhere in the middle. Two identical blocks connected to ideal springs are oscillating. Okay. A and B over time are shown. Okay. Why are the periods different for blocks A and B? Well, in a mathematical definition, they have different amplitudes. Block B has a shorter period because that's a larger spring constant. I think that's what it is. Yeah! A cart of mass m moves to the right on a frictionless track at speed v. The cart collides and sticks to another cart moving to the right at speed v2 with mass 3m. I didn't even comprehend what I just read. A cart of mass m moves to the right. Wait, a cart moves to the right on a frictionless track. The cart collides and sticks to another cart moving to the right. Which of the following quantities are conserved during the collision? Kinetic energy is conserved? Oh, wait, both momentum and kinetic. Oh, wow, okay. I don't know. A block attached to an ideal spring oscillates horizontally with frequency. Okay. Amplitude, spring constant. What is the mass of the block? Well, this looks like 75 times 0.55. I honestly don't know what I'm doing. Oh my god, really? You can't... It doesn't know how to do decimals. Wow. 75 times 55 divided by 100. And then, what is the units for Newton? Oh shoot, I completely forgot. Times 4? Sorry, times 4 or divide by 4? It wants 2 sig figs. Okay, maybe it's divide by 4. 41.25 divided by 4. 10? I don't even know them. Oh, it's a formula that I don't know of. 0.12. Okay, well. Holy shit. A student, oh, I was about to say, is this it? A student wants to create a transverse wave with a vertical slinky. Okay. I don't know what this, okay. Which direction should the student move their hand? A transverse wave? I forgot what a transverse wave is. If you want to do a transverse wave, I guess up and down? Oh, okay, so, wow. I don't even know what transverse means. A sloth is climbing vertically. Its motion is shown on the graph. Okay. What is the instantaneous velocity? Oh, fuck. Oh no, don't do this to me. No. I don't. Who memorizes applied calculus? Come on. I don't. God damn it. No. Don't do this to me. Instantaneous. Oh, God. Who would pay attention to stuff like this? Instantaneous velocity of the. God damn. Well, at 8 seconds, instantaneous velocity is like, uh, oh, wait a minute. This is 3.5 divided by 8. 8.5 divided by 8. What's 3.5 divided by 8? 3.5 divided by 8. 0.43. Oh, I am so off. Okay. Well then okay, so in that case, then I guess it's just a slope here then. That would be what? Rise over run 3 halves. So 1.5. Okay. Oh god. Below is a diagram of a circuit. Which type of circuit is this? Oh no! That looks like a... Oh, is this a switch? I think this is a battery. I forgot what this is. A resistor? Uh, this is a open circuit? Yeah! I literally just guessed there. A transverse wave on a string travels at the vertical position. What is the wavelength of the wave along this? Oh god. Oh no. Don't do this to me. 2? I don't remember. Oh no. I don't remember. I don't remember the 21st night of my physics class. Oh my god. I don't. What is this? Wait, a string travels at 10. Yeah, I don't know. Why can't I? Here you go. 2. Oh, 10 divided by a half. Yeah, I don't remember that formula, but okay. Okay, 20 meters then. Oh my god, I'm almost done, please. A student builds the circuit below. What is the resistance of R? I don't know. Uh, mm, oh god, it's 20 volts. Uh, sheesh. What? It's 2, 4? No. Is it? Mm, I don't know. What is? Here's a hint. I don't. Oh, 100. Oh, it's the other way. I guess. A strength of length L vibrates with a frequency of 8 Hz with 2 antinodes. What oscillation frequency of this spring produces? Well, 2, 8 Hz creates 2 antinodes. Then, let me actually, I'm so lazy to, I'm just gonna, let's see, 8, 8 Hertz, 8 Hertz makes 2 antinodes. Then how many antinodes, no, how many Hertz makes 3 antinodes? Well, in that case, this would be for the 12, I guess. Wow, that actually worked. Okay, thanks, math. A caterpillar crawls 3 meters to find a leaf. Caterpillar's displacement vector is shown below. Which diagram shows the vertical and horizontal components of the caterpillar's Oh god. Wait, hold on, let me reread this. A caterpillar crawls 3 meters to find a leaf. Okay. This? Yeah! Steven applies a force F to a disk halfway between its axle and outer edge at radius divided by 2. This can rotate without friction around its center. How should Steven change the location of the force to increase the magnitude of angular acceleration? Steve should apply the force closer to the axle. A. I was wrong. Then in that case, Steve should apply force. Oh, wait a minute, maybe he can't. Maybe Steven can't. Oh, then I guess this then. Oh my god, leave me alone! Jeez. Okay, a block attached to an ideal. Oh god, why? Without friction on a horizontal table, a student makes the following measure on the block. Cool. What is the maximum kinetic energy of the block? Uh. Ah. Hmm. The answer is C. Dang. I don't know. This looks like 8.8. Okay. A block of cheese is pulled on a string and remains at rest. What is the correct? Oh god, stop with these free body diagrams. Oh god. The flashbacks. Oh god. String is being pulled. A cheese is pulled on by a string and remains at rest. Tension is this way? Wait. Oh god. I don't remember tension. Okay, well, because it's the only tension force here, it's not A. Friction. But it's remaining at rest. It remains at rest, so maybe it's D. I guess there is friction then. Well, then in that case, friction is being this way then. Oh, but it didn't say frictionless, so alright. Show me my summary. Oh god. Yeah, that sounds about right, 33%. If it was curved, it'd be 50%, so you know what, that's normal. Oh god, and now we have mother freaking G main. Oh god, units and measurements. Here, let's see how bad units and measurements can be. Oh, okay. Fractional error. Wow, it's that horrible. Well, I mean, I don't depression. What is this? If velocity, time, and force are chosen at the base quantities, the dimensions of the mass will be uh wait, hold on. You call this units and measurements? Wait, what? Which the following equation is dimensionally incorrect. What is this? An element? Why is there an element set? Partial derivatives? What is this? Oh, this is nasty. Oh, this is no. No. Hold up. What? The dimensional formula of what? It's horrible. Even MIT don't do this. Like this is like for like this is like non-standard physics here. Oh God. Oh God, if that's horrible then uh oh I can imagine what these would look like. Oh God. Oh, is there circuits? Or circuits? I wonder if they have like oh they probably don't. But oh God. Maybe it's here. But I can imagine like disgusting diagrams. Oh, maybe they don't do diagrams at all. That's nasty. That's that's terrible. Oh God. Oh, here yeah, perfect. Oh boy, for the given circuit in the current I, okay, when the key enclosed what? Wait, hold on. For the given circuit, the current I through the battery and the key enclosed. Is this a grammar typo? And the steady state has been reached is if we close this, then this, I don't know. I mean, I guess because of this resistor, it'll be 25? 10. Oh, damn. Close enough, I guess. Inductor. Oh, man. Oh, shoot. Oh, God, I'm getting flashbacks. Oh, God. Oh, God, statements. Oh, God, capacitors. Oh,